clutch for the power feed mechanism on the Barry lathe was worn out beyond usable limits. An attempt was made to repair the issue in a previous video. However, the repair was a total failure. The clutch would no longer disengage, essentially rendering it unusable. Another more reasoned approach will be used in this video. Removing the apron from the lathe is a rather simple task. First, the Z-axis DRO must be decoupled from the carriage, and then the bolts used to fasten the carriage to the apron can be removed, allowing the apron to be separated. After separating the apron, the far lead screw mount must then be removed. This allows for a complete removal of the apron. As the apron has significant weight, one would probably be well advised to use some form of a clamp to hold the lead screw in place and support the load while the mount is being removed. There will be a large bending moment at the drive end of the lead screw, potentially damaging the screw or housing. Here we have the apron on the workbench. The clutch mechanism is located behind the cover plate. Upon disassembling the clutch mechanism, we can see that the friction material made from bicycle inner tube did not remain adhered to the steel discs. Gasket sealant was used as an adhesive. The discs must be thoroughly cleaned of all remaining gasket sealant before continuing with the work. The combination of scraping and ultrasonic cleaning in an ethanol solution was used to prepare the discs. New friction material was cut from cork sheet obtained from the local craft shop. The discs were cut to have approximately 1 mm clearance on both the inner and outer diameters of the steel plates, allowing for any misalignment during assembly. High strength epoxy was used as an adhesive to join the friction material to the steel plates, and the plates were then lightly pressed in an oven maintained at 50 degrees Celsius. This was for approximately 6 hours and allowed for curing the epoxy. After curing, the clutch discs needed to be lapped to size in order to fit the assembly. Lapping was performed using 240 grit emery paper on a flat glass backing, and the plates were regularly inspected for thickness and taper. Without being lapped to size, the clutch mechanism would remain permanently engaged, as the cover plate on the apron would interfere with the mechanism. I'm unsure exactly how much clearance is required. I don't know if the cork will swell over time with the oil. Many sources indicate cork is essentially impermeable, so I don't expect a great deal of swelling to occur. Lapping was stopped when approximately half a millimeter of clearance between the cover plate and stacked mechanism was obtained. Here we can see the finished clutch discs, ready for assembly within the apron. A plain disc is placed in direct contact with the housing. A cork-coated disc is then placed on top of the plain disc. This stacking sequence is repeated, and finally the spring-loaded actuation bolt is installed, in direct contact with the friction material. Clearance between the clutch mechanism and the cover plate is inspected using a straight edge before final assembly. New gasket sealant is placed on the cover plate, and the mechanism is filled with ISO 68 way oil before the lathe is reassembled and tests are performed. The newly repaired mechanism may be tested by engaging the clutch and applying a load to the hand wheels or the carriage itself. Both the longitudinal and cross feeds appear to be functioning perfectly. The clutch disengages easily when the actuation knob is loosened. The final test to be performed before signing off on the repair is to take a test cut in steel. In this case, the steel is 4340 and approximately 55 mm in diameter. The feed appears to be smooth and consistent, resulting in a good surface finish.